What is weight? If you want to understand, suppose if you dive deep down into the sea, you need special kind of oxygen cylinders because you won't be able to breathe. There is a definite depth beyond which you can't dive in because you won't be able to breathe. And you know that atmosphere, the blanket, the air blanket surrounding the earth exerts pressure. If you want to really understand the pressure exerted by this atmosphere, the pressure exerted by the water or the ocean beneath, all those things, if you want to understand, you first have to understand about weight. So let's first talk about weight. We'll first understand what is weight, then we will talk about pressure. So what is weight? Here I would like to review Newton's second law. Newton's second law says that force is proportional to rate of change of momentum. That means change in momentum per unit time. That means change in momentum for every 1 second. But force can also be written as, from this you can write, we have derived, I hope you remember this, force is the product of mass and acceleration. This we derived in our last chapter. Force is measured in Newton, in the name of the scientist Newton. So the force is measured in Newton. When you write the abbreviation N or Newton with first letter, small letter. So the unit of force is Newton. This 1 Newton is actually this mass into acceleration. Mass is measured in kilogram, acceleration is measured in meter per second square. So 1 Newton is actually kilogram meter per second square. This is force. We know that force is the product of mass and acceleration. And in the chapter measurement and motion, we have also discussed about acceleration. Acceleration is change in velocity per unit time. That means the change in velocity in 1 second. If you drop object, the object is going downwards. That means the speed is increasing. So that means that the velocity is changing. Why is it changing? The earth is pulling it down. When the earth is pulling it down, it is changing the speed. That means here the velocity. Because it is changing the velocity, there is acceleration. Whenever you take any planet for that matter, not just earth, whenever an object is just released, that object is falling towards the planet's surface. That means the planet is actually attracting every object towards its center. In the process of attraction, it is changing its velocity. Because it is changing its velocity, there is acceleration. So acceleration, because whenever an object is released near a planet, that object is accelerating towards the planet. We can say that the object is accelerating towards the planet. So it is accelerating. So the acceleration given to an object by the planet is called, in simple terms, gravity or gravitational acceleration. The acceleration by the planet or given by the planet, the acceleration given by the planet on objects is called simply gravity of the planet, gravity or gravitational acceleration. Gravitational acceleration. So gravitational acceleration is nothing but a type of acceleration. That's it. If there is an external acceleration by an external force, we simply call it an acceleration. If the acceleration is given by the planet, we call it gravity or gravitational acceleration. You know that force is the product of mass and acceleration, and gravitational force is the product of mass and gravitational acceleration. So the gravitational force is called weight. So weight is nothing but force. What force is that? Gravitational force. How do we find gravitational force? We have to multiply the mass of the object by the gravitational acceleration of the planet. So the gravitational acceleration at different points it will be different. But near the surface, almost it is uniform. Near the surface of a planet, it is almost uniform. Near the moon surface, acceleration is about 2 meter per second square. Near the earth surface, gravitational acceleration is 9.8 meter per second square. So what I usually do is I will approximate it to 10 so that it will be easier for you in doing calculation. So approximately we will be seeing gravitational acceleration is 10 meter per second square. So whenever you multiply mass of an object with gravitational acceleration of the earth, you will get the gravitational force acting on the object by the planet earth. Whenever the same thing, this is the earth surface, this is the moon surface. Near here acceleration due to gravity is 10 units. Here near the moon it is only 2 units, 2 meter per second square, 10 meter per second square. Suppose you take 10 kilogram of object on earth, the same 10 kilogram of object on moon. Here the gravitational force due to earth on this mass is called weight on earth. The weight on earth is mass of the object into gravity on earth. So what is the weight on moon? Weight on moon is mass into gravity on the moon surface. What is the mass we have taken here? 10 kilogram. So 10 kilogram into, then the acceleration due to gravity, here the surface is 10. 10 into 10, which is 100. So since this is nothing but a force, weight must be measured. Weight is nothing but gravitational force. If force is measured in Newton, weight is also measured in Newton, then the force on 10 kilogram of object on the earth surface is 100 Newton. What is the weight on the moon surface? Mass, the same mass we are taking there, 10 kilogram. So the mass does not change from place to place, but moon's acceleration is 2 meter per second square. Then it is 20 kilogram meter per second square. We have already said that kilogram meter per second square is Newton. So it is 20 Newton. Same 10 kilogram mass on earth surface, it experiences 100 Newton force. On the moon surface, it experiences only 20 Newton force. You just go search for that famous thing that we last time talked about, the feather and hammer experiment on moon surface. The hammer and the feather, they both fall down at the same rate because there is no atmosphere. At the same time, the hammer and feather goes down very slowly because the same hammer of 10 kilogram of mass, let's assume it's a hammer, and goes down faster because it exerts 100 Newton force. The same hammer of 10 kilogram mass on the moon surface experiences only 20 Newton force, hence it goes down slowly. One thing to be understood very clearly, weight is nothing but gravitational force. Whatever is the nature of force, the same is the nature of weight. Weight is a vector because weight is force. Then the unit of weight is Newton but not kilogram. Whenever we are asked to say what is your weight, we usually say it's 40 kilogram, 80 kilogram, 100 kilogram. See, that is a common misconception that we are not supposed to say that. But it is understood and agreed, so let's go on using that. But otherwise, if someone asks you what is your weight, suppose you're studying around 8th standard, maybe around 40 kilogram. So you don't say that 40 into 10 around 400. So without saying 400 Newton, if you say 400, they'll be shocked. So weight is nothing but gravitational force, and that must be measured in Newton. The weight is different at different points, because at the pole, suppose this is the equator, this is the pole. Pole has got more gravitational acceleration value, and near the equator it will be less. Suppose 10 kilogram near the pole, it will experience 100 Newton, means here it will experience only 97 Newton. It will be very less here. So the weight of an object is different at different positions of the planet, different places of the planet, because see, the weight of 10 kilogram of object on earth is 100 Newton, but on moon is 20 Newton. So mass is different. Mass is measured in kilogram, weight is measured in Newton. And weight is the product of mass and gravity of the planet. and weight is measured in Newton, and weight has got direction. Weight has got direction. Here the weight of any object is towards the center of the planet. If it is Earth, it is towards the center of the Earth. That's what we need to understand. So once we understood weight is nothing but force, then it will be easier for us to study about pressure. In the next video, we'll talk about pressure. Then thereby we will go on to talking about atmospheric pressure, so and so things.